in this example, what we want to do is determine the magnitude of f, so what this magnitude is, and the direction that f is in space by figuring out its directional angles. We're given a few pieces of information. The first piece of information we're given this vector t, and this vector t has a magnitude of 5.4 kilonewton and is directly along the x-axis. We're also told that we have some vector r right along here, and the angle between t and r is 40 degrees, and the angle between r and f is 30 degrees. Now, how to go about this problem? The first thing I'm going to do is I need a starting point. And the starting point to figure out the magnitude is I'm going to figure out I've decided I want to figure out all the components of x. F. I want to figure out f of x, f of y, and f of z. And if I square all those components, add them together, and take the square root, I'm going to have the magnitude. So my magnitude of f is equal to the square root of f x squared plus f y squared plus f z squared. Okay. Now I know f of x. I know f of x is equal to t, which is equal to 5.4 kilonewtons. So that one's easy. Now, when I was drawing all these different vectors in, I sort of noticed I have all these right triangles. I have some right triangle right here, and I have another right triangle right here. So I'm going to try to use SOHCAHTOA with these right triangles to figure out these components. And what I'm going to do is I'm going to look at this bottom triangle first. So when I look at this bottom triangle, this would be t. This would be my fy. I do need to notice that it doesn't really matter to figure out the magnitude, but fy is pointing against this positive y direction. So my component of fy is going to have to be negative. Now, when I square it, it doesn't matter, but it is negative. So I have fy. I have 5.4. But right now, negatives, it doesn't make sense because we're dealing with lengths of a triangle. And this is vector r. This angle in here is 40 degrees. So what I want to do is figure out what fy is. If I use SOHCAHTOA, I see that for fy, this is opposite, this is adjacent. So opposite and adjacent, I'm going to use tangent. If I use the tangent of 40, this is going to be equal to fy over 5.4. So fy is going to be equal to 5.4 times the tangent of 40. And that is equal to 4.5. We'll call this 4.5. 4.5 kilonewtons. So fy is equal to 4.5 kilonewtons. All right, so I do need to get fz. And to get fz, it looks like I need to use this triangle right here. This angle, this length right here will be fz. Oh, and don't forget, I did say it was equal to minus 4.5. So we need to get this length of this triangle. If we just look at this triangle right now, we don't have any pieces of information. We need to figure out what r is, and then we'll have two pieces of information. R, we can get that from my first triangle. R is hypotenuse. Then I'm going to use the 5.4. So I'm going to use this adjacent, hypotenuse, and I'll need to use the cosine. So I'll have the cosine of 40 is equal to adjacent, so 5.4 over r. So r is going to be equal to 5.4 divided by the cosine of 40. And we get this is, we'll call this 7.05. We'll just call it 7 for simplicity. We'll call this 7 kilonewtons. Okay, so r, the length right here, is 7 kilonewtons. Now I can draw this new triangle. When I draw this new triangle, I have what r is equal to. This is r. This is 7 kilonewtons. This right here is fz. And this is my vector f. This angle right here is 30 degrees. And right now I actually see I can directly solve for what this magnitude is just by using r. And we'll do it both ways just to verify. But I'm going to stay on the first idea I had, which was determining this vector. So f of z is opposite. This is adjacent. So opposite and adjacent is going to be the tangent. So I'm going to have the tangent of 30 is equal to fz over 7. So fz is going to be equal to 7 times the tangent of 30. And that's going to be equal to 7 tangent of 30. We'll call this 4. We'll call this 4 kilonewtons. So Fz is 4 kilonewtons. Now I'm going to put this in this formula right here. I'm going to have this is equal to the square root of 5.4 squared plus minus 4.5 squared. If you're using this, it's important that that minus sign is inside the parentheses, plus 4 squared. So we'll have 5.4 squared plus minus 4.5 squared plus 4 squared, and we'll take the square root. We get we'll call it 8.1. This is equal to 8.1 kilonewtons. All right, let's just verify this. That we could have just used this triangle to figure that out if I was solving for f using r. So if I was solving for f using r, I would have the hypotenuse, adjacent, the cosine. So the cosine of 30 is equal to the adjacent, so 7, divided by f. So f is going to be equal to 7 over the cosine of 30. 7 divided by the cosine of 30 will give me, there's a couple of rounding things I did, but it gives me the same answer. So this is equal to 8.1. So if you had seen that, it would have saved you a few steps, but I wanted to stay with my original idea to figure out the magnitude. All right, so now that we figured out the magnitude, how long f is, 8.1 kilonewtons, we want to figure out the cosine angles. So my directional cosines, I have a few equations. I have the cosine of alpha is equal to f of x over f, and this is the magnitude of f. I have the cosine of beta is equal to f y over the magnitude of f, and I have the cosine of gamma is equal to fz over the magnitude of f. And now you see why I wanted to stay with my original way of doing this, because I'm going to need all of these different components. I'm going to need to have these components to figure out what alpha, beta, and gamma are. So let's start with alpha. To solve for alpha, and I'll do it right here, to solve for alpha, and this is going to be the same for beta and gamma, I need to take the inverse cosine of f of x over the magnitude of f, right? To get rid of the cosine on this side of the equation, I need to take the inverse cosine. And what I do to one side, I need to do to the other. So when I see alpha, I have alpha is equal to the inverse cosine of f of x, 5.4, over my magnitude, which is 8.1. Cosine of 5.4 divided by 8.1. I get this angle is 48.2 degrees. Okay, I'm going to do the same thing with beta. Beta is equal to the inverse cosine. Well, instead of f of x, we're going to use f of y. F of y is minus 4.5 over 8.1 minus inverse cosine minus 4.5 divided by 8.1. This is 123.7. And then gamma will be the inverse cosine of 4, my f of z, divided by the magnitude, 8.1, inverse cosine of 4 divided by 8.1, and we get 60.4. 60.4 degrees. So what does this mean? This means if I have, let me draw this final vector. If I have this vector right here, and this is my x, this is my y, so my vector is somewhere over here. The length is 8.1 kilonewtons. Now, the angles, now this is somewhere in this part of the coordinate system. The angles from the positive x-axis, like that, is 48.2 degrees. The angle from the y-axis is 123.7 degrees. And the angle from this z-axis is 60.4 degrees. And now this defines where this vector is in space. If this video was helpful, please consider subscribing to my channel by clicking the button above my head. By clicking subscribe and clicking like, it helps me build viewership and helps more people with problems like this. It makes my videos easier to find. If you're looking for other statics problems, please look at the playlist to my left, and hopefully something will be able to help you.